Hello, welcome to Termite Machine Works. My name is Keith. Yesterday I had a project here and I lost my intro, so this is what we got. We got a 690 loader, front axle, four-wheel drive, steering knuckle, and we repaired the other end of it, and here's how it went. Even just running snap gauges through here, I'm checking the dimensions here, and I can feel with my finger a little wear where this bearing is sit in there, and I can see that the face on the back side here is a little skidded, so this has rotated in here, and that's they don't want to do anything with this end, so I would reassemble this with some Loctite for the final assembly there. Well, we're reaching in just past that, and we decided, you know, it's only about 3/8 wide in there, so we want to get in there with an actual inside micrometer. And we get a real accurate measurement of virgin material in there that's representing the same bore. We're getting about 1/1000th less on the diameter in there versus where the wear is, so it confirms our finger feel there anyway. Yeah, and she has a little tiny bit of egg, but we can get the gist of what our diameter is going to be. Here's a pretty good view looking through the one bore into the other, and you can really see the scuffing that's in here. We got some metal really missing in this section right here, and this material that's missing here goes all the way out to the edge of the face. It almost looks like a true hole on the outside, but it's right at that edge right there. This remainder of that race, we're going to knock that out before we start cutting, and we're going to dress clean all the surfaces where we're going to want to add braze and come up with some good clean metal to work with. Alright, here's a good look at the outside of the worn out hole, and you can see that it's just starting to really crest this surface right here. There's a little bit of gap in that bearing there. Alright, we got this faceplate in here. We just turned a set of props, and this is an ideal situation to go ahead and take one job after the other without having to change up a chuck or whatever. That knuckle there, and it would be extremely hard to get in there and hold it to turn it. And what we're going to do is we're going to make a jig to turn that knuckle, and we're going to use this dog plate. This is actually a dog plate. This is where the dogs normally ride. I have drilled and tapped it out for a lot of different uses as well, including the prop boring jig, and this is the back plate for it. We have a jig here that we made several years back. In fact, I forgot what I actually used this for. I figure if you forgot what you used it for, it's okay to go ahead and modify on it to suit your new job, and that's what we're going to do. This originally hole pattern was configured for the small rotary table, and we're going to pick up these three here, but the hole diameter on our 3-hole pattern in the faceplate here is a little different, and it's a different size bolt. So we're going to open those up there, and then we're going to mount this on here. We're going to turn this register to suit the good bearing in on that knuckle, and so let's get going and get this done, and we'll get back in here and whittle this down. Alright, we're not getting real fancy with this. We're using a turbo end mill, easy cutting. I mean, this flange is hanging out here, and we're clamping way in here with the super spacer. And we're just indexing it for 3 points so that we know that it's uniform. So we aren't destroying the actual original bolting pattern, we're just adding to it. So I gave all my slots about 10,000 clearance in there. And, okay, number 3 right there. Alright, now we slide that over there, we get the next one, last one in. Alright, just because I got a little bit of clearance, I have a little motion in there. So let's tighten it down. Let's see how true we're running before we even take a cut or try to tap it in the... Alright, we got a second thick washer in there, and she's not rattling no more. Alright, let's see what we got. Throw an indicator on it. Almost 30,000, so all we got to do is move it 15. Let's see if we can get 15 out of it. Alright, we're within 3. We're going to give it a little tiny bit of tension here. Making sure that we are. Alright. Alright, we're running within a half a thousandth. We're going to snug this up pretty good now. Alright, we're going to go ahead and we know that this is about a 1/4 inch long to our bore in there, and we want to have a positive hold in here. That bearing is going to slip over here, rest against this face, locate in this diameter here, and be held with a flat bar using that 1/2 inch all thread hole there. Okay, like 462. That's 10. And a kiss off the face. Okay, 42, so it looks like we might have to polish that about 1,000. Let's just check our fit. See how we're looking. Yeah, she wants to start. Okay, I believe we're going to have a good fit now. We want the thing to be able to come on and off because we may use this jig to hold it in a weld position or two. And then remount it in here, so... yeah. Alright. Just slightly shallow of this surface right here. Now we're going to get our retainer plate set up, and then we'll be able to rotate this around. We got clearance around our table. Alright, we'll go hunt up a disc or a mill clamp or something. It didn't take us too long to find a couple rings that we had over at the hydraulic press. And I think the stack up's going to work up fine here. Although I think I just grabbed too long of a stud here. Let's just say, yeah, let me grab a shorter stud. Even cutting that off, we had more than enough threads in that bore there. I had done them extra deep there. Little compensation washers there. Alright. All right, nice and secure. Now we already tapped out this other part of the race here. That's what was left. All right, here we go. This is running pretty damn true, maybe a couple thousand, but it's deceiving because it has a little wear and cutout area there, so it's kind of deceiving on that line there. But this is the way that we're going to set this up, and we're going to create a true running bore with the other bore because we know our setup. When you're swinging things like this in a lathe, you've got an offset balance here. This isn't extreme, but you can hear the noise of the lathe, and you can hear when the weight is being picked up and when it's been dropped off the other side. Alright, we're going to put a boring bar to this hole and get it prepped for brazing. Alright, we're just going to take increments of 25 per side. You can hear a little chatter. We're going to put our other boring bar in here when it comes to finishing so that we can get a better grip on less tool pressure. Your inserts will tend to carry a lot of tool pressure, and we're hanging this thing out a little bit. I call that harmonics. And I spell it W-H-O-R-E. Okay, here's a look at our first skim, and I can see herringbone finish. It's typical of harmonics messing you up. You can see that the void here. We're only going to take a certain amount out to actually make the inner portion of our braze buildup, and then we'll rotary burr most of this out, and we'll add to that out to this diameter, and then do the full wrap around here. A little hollow back in that back area there and right there. So, right there, I mean, you can see how close she was to wearing it all the way through. And actually, you know, before that diameter, it was right at the face, right into the chamfer. On this pass here, we stepped up our feed rate and to rid of some of the chatter, and it's doing a pretty good job. Create more tool pressure, and sometimes you can cut back on your chatter, vibration, harmonics. Alright, we've taken 75 thousandths off of each side there, and we're going to be happy with that as far as our braze buildup around our bearing, creating a new shell all the way around. We're pretty much done in the lathe here, and we'll take it on in and start rotary burn and cleaning up the inside where it's going to need more material even yet. That looks pretty clean. Get the crunchies off. Alright, I think we're fully prepped, ready to start brazing.